Okay, so ionic bonding leads to ionic compounds. If I have an ionic compound, there are some things we have to remember. There's a complete transfer of electrons. We talked about that yesterday. The goal, or goals, I guess we should say, would be a full outer shell for all atoms, and to create a neutral compound. Now, I'll let you write that, then I'm going to ask you a question. We'll see if you can remember. Without looking in your notes, see if you can remember from yesterday, what two things bond to make an ionic compound? Drake, are you telepathic? Did you know what I was going to ask you?
I know what you're going to ask.
What two things bond?
I think it's a metal and a non-metal.
Good. They're formed by a metal bonded to a non-metal. So yesterday we took that list and we looked at it to see if we could figure out what was what. The metal will be your cation, and the non-metal will be your anion. It always works that way. And you always write the cation first. So it's always first in the compound. So if I say something like lithium fluoride, and I say which part's the cation, it's the first part, it's the lithium. They can be formed with monatomic or polyatomic ions. So we have to talk about what those are. Let's talk about monatomic first. So a monatomic ion, those are the ones that are right off the PT. Right off the periodic table. I just go look them up and I figure out the charge based on what group they're in. It's an ion made of only one atom. Now, once you get that written, get out your mercury and mercury 2. I need to get one of those papers so I don't give you things you don't have. Yeah. Get out your mercury 1, mercury 2 card. And also pull out your sulfate card while you're at it. Mercury 1, mercury 2, sulfate. So mercury 1, mercury 2 sulfate. Find them, flip them to their formulas. Mercury 1, mercury 2 sulfate. So when I write mercury 1, it is Hg2, 2 plus. Mercury 2 is just Hg, 2 plus. And sulfate is SO4, 2 minus. Check your cards and make sure that's what you have. I'm going to ask you first, which one of these three would I consider a monatomic ion? See if you can figure that out. Which one of these three would I figure a monatomic, or call a monatomic ion? Cole, what are you going to say?
Mercury 2.
Cole says mercury 2. Xander, what were you going to say? Drake, what were you going to say?
Mercury 2.
You think they're right? How many of you would pick that? Yeah, look. It has a charge, but there's only one of them. What would these two probably be called? Polyatomic, yeah. So this is a mon. This is a polyatomic. So let's look at polyatomic really quickly. Oh no, wait. I'm going to go on with monatomic for just a minute so I can show you something. If I have monatomic, normally we find the charge from the periodic table. If not, there are two ways we can figure it out. The first way is called the stock system. And we use Roman numerals to tell the charge to us. So stock system is a system of naming that uses Roman numerals. Find, let's see, out of your cards, find iron 2 and iron 3. So I ask you to find iron 2, that's the way that would be written, and iron, I'm using Roman numerals, 3. When you find iron 2, Jacob, what's its chemical formula?
Mercury thing. Things look kind of backwards for me.
Don't think about mercury. Mercury is like one of the weirdos.
Okay.
That's why I had you get out iron, and we're going to get out lead and look at it too.
Okay, then would
So iron 2,
this be iron and then 2 plus then?
yes, Fe 2 plus. Iron 3, what does your card read?
Iron and that 3 plus.
Yeah. So this is the normal way it shows up. Mercury is a weirdo. It has a whole bunch of different forms. We're not going to use it for an example, and I'm not going to try to trick you with it ever. until maybe Chem 2, but not in Chem 1 will I try to trick you. No, I won't ever try to intentionally trick you. See how the Roman numeral lines up with the charge? So that helps a lot. If you look at iron 2 and 3, or lead 2 and 4, maybe pull out the leads also, because this leads me to my second way of naming. So a lot of these things, remember how I told you transition metals were weirdos? Well, they make multiple forms of ions lots of times. So we have to look at them and we have to go, which one has less charge, which one has more, or what's the higher number? The one with less charge, what's the ending on all of those with the lower charge? Like if you compare lead 2 versus lead 4, or, I'm sorry, iron 2 versus iron 3, or your leads, how do the lower ones end? What's the suffix on them?
Plus.
The suffix. Do you know what a suffix is, prefix and suffix?
Yeah.
So how do they end, Cole?
OUS.
Yep. If it has a lower charge, it's OUS. And if it has a higher charge,
Ick.
it's ick. That's how you would know the difference. Like if I said ferrous versus ferric, this would be iron is ferrous. So this would be ferrous, this would be ferric. The reason I gave you that little list at the bottom is because those are the elements that have strange names when they become ions. Everything else is just as it is off the periodic table. So I would call this guy ferrous and this guy ferric. Personally, I much prefer the stock system. It's way easier than remembering us and ick and which one's which. All right. Now let's look at your polyatomic ones for just a little bit. Okay, so polyatomic are different from monatomic. These are two or more of the same or different atoms combined. The charge on them is from the combined atoms. So they don't have, each part of it doesn't have an individual charge. It's the charge on the whole thing. And they have different names than what's on the PT. They're easy to figure out because they have different names. So all of those things that you made cards for, that are like SO4, 2 minus, PO4, 3 minus, Hg2, 2 plus, all of those things are polyatomic ions. Monatomic are easy to figure out. So now, the challenge is making neutral compounds. And that's what we're going to do. And we're going to start with the monatomic ones. When you're working with monatomic, you can just go to your PT. And I'm going to tell you, we'll work through one. Let's see. A compound forms between copper 2 and chlorine. Now, the first thing I want you to do is go to your periodic table and figure out which one, and you might not even have to go to your periodic table at this point, which one's a metal, which one's a non-metal.
Copper.
Okay, so here's my metal, here's my non-metal. What's really nice, what did I do for you? I gave you the stock system. Copper falls in the transition metals, does it not? Look at that. Yeah? So we don't automatically know it's charged, but guess what? Now you do. What's the charge on copper?
2.
So I would write that Cu, 2 plus chlorine has no Roman numeral. There's nothing weird about it. What group's chlorine in? Halogens, which is group 7 or 17. Either one is right. How many electrons does chlorine have in its outer shell? 7. How many does it want? 1. It wants 8. You're right. It wants 8. It wants to gain 1 more. Be careful how I say that. So what ion does chlorine form? Cl, anion. What's its charge? Good. Cl minus. Now, when I visualize this, I can do this, when I figure this out, I can do it 3 different ways. One way, if you're a visual person, draw out your charges. And then look at your charges. I have 2 plus over here and only 1 minus. Is that going to cancel out and be neutral? No. So then I would say to myself, what is the least common multiple between 1 and 2? What?
1. Wait, at least
2.
oh, I was thinking great
1 times 2 is
factor.
2. I can do it that way, but I'm going to show you the easiest way to do this. And rarely does it not work. Sometimes you have to double check. Once you get this figured out correctly, it balances out if what this is like a 1 minus, right? If I treat this as my superscript over here, and I treat this as superscript, not superscript, subscript, as my subscript over here. 1 times 2 is 2. So I want a 2 plus and a 2 minus. Which means I would have to multiply chlorine times 2 and have 2 of them, and now I have neutral, correct? So if I wrote that, I would write it as CuCl2. That works. There's a 1 here. There's a 2 here if I crisscross my numbers. That makes sense? The first time it's a little like weird, but you'll get the hang of it quick. So there's 3 different ways you can do it. You can draw it all out. I don't like that one, but if you do, yay you. Least common multiple, I would be sure I could do that. I go 1 times 2, so I want them both to equal 2. That's what that tells me. I can get this to equal 2 by leaving it alone. I can get this to equal 2 by multiplying it by 2, which tells me I need 2 of them. Be sure you can do that, because there will be a case where you might have to. Or I can just flip-flop and make my superscripts become my subscripts. Now, the question is, I have this copper chloride, copper CuCl2, and I have to know how to name it, which I just said the name like 5 times, but anyhow, this is just what it is off the periodic table. Whatever it says on the periodic table, that's what it is. This, I take the name from the periodic table, I drop the ending, and I add IDE. So I have chloride instead of chlorine. if I used something like, let me find another one here real quick. If I used sulfur, for an example, I would drop the and add IDE, and it becomes sulfide. So it's not real hard to do. This IDE is your dead giveaway. You're working with a monatomic anion. It's an ionic compound. And we're going to practice with these so it'll become more familiar. Yeah.
Where does the mate come from on the other
Oh, the Nate, because when we have polyatomics, they have all different endings. There's eights, there's ites, there's a lot of different ones. So based on the series and the charge, that's how you get the ending. And it's kind of complicated. We spend some time on that in Chem 2, but in Chem 1 we just work with them we don't figure out their names. Yes.
With the stock system, how do you know if it's going to be a negative or positive? Oh, I guess it's where it's out.
Yeah, based on what it is. If it's, yeah. There are no anions that are part of the stock system. If it's got Roman numerals, it's a metal, it's positive. Okay, I want you guys to try this. Wait, let me look at something. Did we name this? Yeah, I started to name it. So I would call this, technically, and we should put this in your notes, copper 2 chloride. Now, I'm going to have you try one. Let's say that I have a bond that's going to form between lithium and oxygen. So I want you to work through it all the way to naming it and see if you can do it. And notice there's no Roman numeral after lithium. It doesn't have multiple forms because it's an alkali metal. See if you can get it. When you think you have it, stand up, just so I know where we're at. Is there anything in this one I need to look through my cards for? Or is everything on the periodic table? What do you think? Yeah, everything's on the periodic table. Do we need to talk about it? Yeah? All right, let's talk about it. You know, I love to talk about chemistry. All right, so when I go to the periodic table, and if you didn't do this, work through this with me. When I go to the periodic table, where is lithium?
Group 1.
Group 1, which tells me it has a charge. Anybody but Drake answer this. Tells me it has a charge of what? Positive 1. I appreciate your enthusiasm. So I'm going to write it like this. Li plus. When I go to oxygen, where is it, Drake?
Group 6.
Group
Group 16.
6 or group 16, either one is correct. And then what is the charge on oxygen since it's in group 16? Good. 2 negative. So, whoops, I should put my negative sign. So if I draw this, I have a plus. And over here, I have 2 minuses. Well, that does not work well. So I have to find my least common multiple. 1 times 2 is 2. How do I make this a 2?
Multiply it by 2.
Yes. So I have to go times 2, which gives me Li plus, or plus, plus, to minus, minus. Am I happy now?
Yes.
Yes. So I would write Li2O. Look at that. This guy came over here. This guy, even though I don't write a 1, came over there. They flip-flopped. Connor, can you name that compound?
Lithium oxide.
Good job. This is lithium oxide. Okay, now, grab that paper that I had you pick up on the way in. I didn't bring one over. Just the first page has all monatomic ions on it. Get together with your little lab group or partner, whatever, and try to get through that first page. If you are having trouble, this is your time to call me over. If you're not here, you need to finish the first page of what I'm putting on what's it called? Google Classroom. Have a great weekend.